Hi, my name is Esteban Herrera. In this video, we're going to talk about Spark, one of the most popular web microframeworks for Java. Don't confuse it with Apache Spark. They have the same name, but they are different projects. We'll cover three topics. What is a Spark? Why it is called a microframework? What are its features? When to use it? The Spark framework fits perfectly for specific use cases, because as the old saying goes, always use the right tool for the job. And how it works. We'll learn about its building blocks and how to program a small service with this framework. After that, you should have a good understanding of what Spark can do and see how easy it is to use. Sounds good? Let's get started. Spark is a microframework for writing web applications. The micro part of the name means it's small and simple. For this reason, Spark comes with a minimal amount of features. This gives us a lot of flexibility because you can structure your application any way you want. You need access to a database, use Hibernate, Spring Data, or plain JDBC. You want to use templates in the view layer, use Velocity, FreeMaker, Handlebars, or many others. Out of the box, Spark runs on an embedded Jetty web server, and you can even change this if you want, although most of the time you won't need to do that. Jetty is a full feature and standard-based server that has a very small footprint, perfect for a micro framework. Because it's light and fast, Spark is mainly used for creating REST APIs and small modular services also known as microservices. But as it also supports many templates engines, it can also be used to create web apps. Okay, at this point you may be wondering, how do I start? Well, first you need to add the Spark core dependency to your project, either with Maven, Gradle, Ivy, or SVT. The next thing you need to know is that the main building block of Spark application is a set of routes. A route is made of three simple parts. A verb that corresponds to an HTTP method like get or post, a path, which is the route the server should listen to and provide a response for, and a callback, a handler function that is invoked to generate and return a response. The callback takes as arguments a request and a response object. Routes are matched in the order they are defined. The first route that matches the request is the one that gets invoked. Get, post, put, delete, and many others are public static methods of the Spark class. They are just statically imported to provide more readable code. Now, when you're ready to deploy your application, you can simply generate a jar file with all your dependencies and execute these files on any platform you want. As you can see, Spark focuses on being simple and straightforward, with no XML configurations or annotations. Now let me walk you through a small example. We are going to code a simple service to generate QR images with the help of the Google Zebra Cruising library. Our service will use a get route, produce a PNG image, define a directory to serve static files, and translate a Java exception to an HTTP status code. Finally, we'll see how this can be implemented with Spring Boot so we can compare both frameworks. Okay, I have already prepared a Maven project for this demo. I'm using Eclipse, but you can use any IDE you want. This is a standard Maven project. Here's the pond.xml file. Here we're declaring as dependencies Spark, the Zebra Crossing library to generate the QR code, and the simple login facade for Java, a library that provides a login API needed by Spark. One important thing is to include the Maven assembly plugin, which in the package phase of the building process is going to pack our application as a jar file with the label jar with dependencies and set in the manifest file com.example.sparkapp as the main class, so we can run the application with a command like java-jar myapp.jar instead of java-cp myapp.jar com.example.sparkapp. This way, under Maven dependencies, you'll see the jar files for Spark, Login, Jetty, WebSocket, Java SE, and others. Alright, in main resources, I already created an HTML file inside a static directory. It's a simple file, just to test that our service can render QR images is called inside the source attribute of an image element with the text http://sparkjava.com, which is of course URL code. There's also a QR util class with the method generate QR code that takes the text that will be in code and the width and height of the resulting image, which is returned as an array of bytes. It uses classes from the zebra crossing library, like bitmatrix and matrix2image grider, to encode the text and write the PNG image as a byte-array output stream. If there's an error at some point, it is logged and returned as a runtime exception. Now let's create that Spark app class that we configure as the main class in the package.com.example with a main method. Okay, let's get a logger instance. Then with a static files location, we specify that the static folder is where we can get our static files. It's important to mention that the directory name is not going to be included in the URL. So our index.html file will be served under localhost and not localhost/static. Then let's define QR code as a get root, extract the text parameter, and if this is different than null and is not empty, we can generate the QR code with a method from the QR util class. Set the response type to image/png and return the array of bytes. If there is no text parameter, we immediately stop the request with halt, specifying the status 400 for a bad request and a message. Also, let's define a handler for the runtime exception. It receives the exception thrown and the request and response objects. In this case, we'll only stop the request with halt, sending the status code 500, internal server error. Finally, we can use the method await initialization to block the current thread until the server is ready to handle requests. We show a message in the log when the server has started, and we're done. Let's test it. If you're working with an IDE and don't want to generate the jar file, you can execute the Spark app class directly with run as Java application. Okay, let's see the log. It started at 404 milliseconds. Wow, that's fast. And as the last line, our message, server started. Great. If we open our browser and go to localhost at port 4567, the default port for Spark, we'll see that the QR image is rendered correctly. Now you may be thinking, okay, Spark seems to be a good framework, but I can do the same with Spring Boot. And I will say, yes, but let me show you something. This is the same app using Spring Boot. The project has the same structure and files, except for the main class. You can see that Spring Boot takes a different approach for programming web apps. It uses annotated methods and in fact, it has fewer lines of code than the Spark version. But let's run it. At the end, the server started in 2.75 seconds. That's almost 7 times of what it took to start the Spark server. If we open the pom.xml file, you can see that we are only defining 2 dependencies, Spring Boot for web and the library to generate the QR image. But look at the number of jar files. Of course, this will be reflected in the size of the application file. 3 megabytes for the Spark jar file versus almost 15 megabytes in the case of the Spring Boot jar file. In some environments or situations, these factors are important, which proves the relevance of the saying, always use the right tool for the job. In summary, Spark is a micro-framework for creating web apps with minimal effort. It's light and fast because it doesn't bring all the bunch of functionality that other frameworks do. And, as we saw in the QR example, these features make it a great fit for programming microservices, APIs, or simple web applications. Now you know about Spark, the web micro-framework. So go and create something amazing. Take care, and thanks for watching.